Welcome to our video on combinations continued, the binomial theorem. Today we'll explore how combinations can be used to expand different power binomials. Before we dive into the binomial theorem, let's quickly review what combinations are. A combination represents the number of ways to select k items from a set of n items, where the order doesn't matter. The formula for combinations is n choose k, which equals n factorial divided by k factorial times n minus k factorial. Now, let's introduce the binomial theorem. The binomial theorem gives us a formula for expanding expressions of the form a plus b raised to the power of n, where n is a positive integer. The theorem states that a plus b raised to the power of n equals the sum from k equals 0 to n of n choose k times a raised to the power of n minus k times b raised to the power of k. Let's break down why this formula works. When we expand a binomial like a plus b raised to power n, we're essentially multiplying a plus b by itself n times. Each term in the expansion comes from choosing either a or b from each of the n factors. The coefficient n choose k counts the number of ways to choose exactly kb's, and consequently nka's, from the n factors. Let's start with a simple example, x plus y squared. Using the binomial theorem, we get the sum from k equals 0 to 2 of 2 choose k times x raised to 2 minus k times y raised to k. When k equals 0, we have 2 choose 0 times x squared times y to the power of 0, which is 1 times x squared times 1, or x squared. When k equals 1, we have 2 choose 1 times x to the power of 1 times y to the power of 1, which is 2 times x times y, or 2xy. When k equals 2, we have 2 choose 2 times x to the power of 0 times y squared, which is 1 times y squared, or y squared. So, x plus y squared equals x squared plus 2xy plus y squared. Let's try a more complex example, a plus b cubed. Using the binomial theorem, we get the sum from k equals 0 to 3 of 3 choose k times a raised to the power of 3 minus k times b raised to the power of k. When k equals 0, we have 3 choose 0 times a cube times b to the power of 0, which is 1 times a cube times 1, or a cubed. When k equals 1, we have 3 choose 1 times a squared times b to the power of 1, which is 3 times a squared times b, or 3a squared b. When k equals 2, we have 3 choose 2 times a to the power of 1 times b squared, which is 3 times a times b squared, or 3ab squared. When k equals 3, we have 3 choose 3 times a to the power of 0 times b cubed, which is 1 times b cubed, or b cubed. So, a plus b cubed equals a cubed plus 3, a squared b plus 3ab squared plus b cubed. The coefficients in the binomial expansion form a famous pattern called Pascal's triangle. Each number in the triangle is the sum of the two numbers directly above it. The numbers in each row of Pascal's triangle are exactly the coefficients in the binomial expansion of a plus b raised to the power corresponding to the row number, starting from row 0. One practical application of the binomial theorem is in probability. Consider a coin flipping experiment, where we flip a fair coin n times and want to find the probability of getting exactly k heads. This probability is given by n choose k times p raised to the power of k times q raised to the power of n minus k, where p is the probability of success, getting heads, and q is the probability of failure, getting tails. For example, if we flip a fair coin 5 times, the probability of getting exactly 3 heads is 5 choose 3 times 0.5 raised to the power of 3 times 0.5 raised to the power of 2, which equals 10 times 0.5 to the power of 5, or 0.3125. A common form of binomial expansion is 1 plus x raised to the power of n. Using the binomial theorem, we get the sum from k equals 0 to n of n choose k times 1 raised to the power of n minus k times x raised to the power of k. Since 1 raised to any power is 1, this simplifies to the sum from k equals 0 to n of n choose k times x raised to the power of k. For example, 1 plus x to the power of 4 equals 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Let's summarize what we've learned about the binomial theorem. The binomial theorem provides a formula for expanding binomials raised to a power n. The coefficients in the expansion are given by combinations, specifically n choose k. These coefficients form Pascal's triangle. The binomial theorem has many applications. including probability and calculus. Remember, a plus b raised to the power of n equals the sum from k equals 0 to n of n choose k times a raised to the power of n minus k times b raised to the power of k. And that's how combinations can be used to expand different power binomials through the binomial theorem. Thanks for watching.